Good afternoon, folks. I am Mike. I am coming back at you with yet another video on college algebra. In the previous video, we talked more about linear functions and linear equations, and we saw real-life applications of those things as well. In this video, we are going to talk about how we can mess around with and tinker with some basic functions and their graphs and see what kind of transformations we can do with their graphs and how do those transformations impact the function that we have. So before we get into the actual transformations, let's just identify some basic functions that we are going to be working with here. First one, the basic identity function, f of x is equal to x. Whatever x value you plug in, I send it right back out at you. Number two, the quadratic or the square function, f of x equals x squared. Whatever you plug in, I give you the square of that. The cube function, f of x equals x cubed. We have the square root function, f of x equals the square root of x. We have the cube root function, f of x equals the cube root of x. That 3 there that's on top of this little downward diagonal line there, that says it's the cube root. Then we have the absolute value function. F of x is the absolute value of x. And then we have the reciprocal function, f of x equals 1 over x. So in the various sample problems that we're going to be doing in this video, we'll be using these 7 functions to talk about transformations of graphs and what these things look like. So the first kind of transformation we can perform is a shift. Just taking the graph of our basic function and moving it up, down, left, or right. And how do these shifts impact the function itself? If we're given a function f of x, we shift it up c units by writing f of x plus c, where c is positive. We can shift it down c units by writing f of x minus c, where c is a positive number. So adding or subtracting a number on the end of the entire function itself will shift it vertically, shift it up or down. We can also shift it horizontally. We can shift it left or right. This gets a little bit more involved, a little bit more complicated. Given a function f of x, we shift it right c units by writing f of the quantity x minus c, where c is positive. So what we mean by f of x minus c here is wherever we have a variable, wherever we have the letter x in our given function f of x, we're going to replace it with the quantity x minus c. This was a horizontal shift to the right. We shift it horizontally to the left by c units if we write f of the quantity x plus c, where c is a positive number. So x minus c is a shift right, x plus c is a shift left. So let's do some practice problems here, writing the function obtained as a result of doing some shifts. We're going to write the function obtained as a result of shifting x cubed right 5 units. So this is a horizontal shift. As we said, we shift it right by writing f of the quantity x minus c. Here, our c value is 5. So instead of just the x, which is raised to that power of 3, wherever we see the x, we're going to substitute in the quantity x minus 5. So x minus 5, that whole quantity cubed, is the graph of x cubed, just shifted right by 5 units. Next, write the function obtained as a resulting of shifting 1 over x down by 4 units. So this is a vertical shift. Vertical shifts, we're adding or subtracting a number onto the end of our function, not the variable or the argument, as the variable is sometimes referred to. So we're shifting down by 4. A vertical shift down means we need to subtract So we are going to have 1 over x turn into 1 over x minus 4. If we want to shift it up by 4, this would be 1 over x plus 4. And now let's do one of each. Let's write the function obtained as a result of shifting the square root of x left by 2 units and then up by 11 units. So we're going to take care of the left shift first. Again, going back, if we want to shift it left by 2, it's going to be f of the quantity x plus 2. So the square root of x will then become the square root of the quantity x plus 2. Then after that, we are going to shift this thing up by 11. That is, we are going to add 11 onto this thing here. So we are going to get the square root of x plus 2 plus 11. The next type of transformation we can do with graphs is a stretch or a compression, aka a shrink. And the way we do vertical stretches, compressions, or horizontal stretches or compressions is we multiply either the function by a constant or we multiply the variable by a constant and we take that quantity and substitute it in. So given a function f of x, we can vertically stretch it by a factor of c by writing c times f of x, where c is greater than 1. We can vertically compress it by a factor of c by writing c times f of x, where c is between 0 and 1. So a vertical compression or stretch, you're taking your function, the entire function, and you're multiplying it by a c value. Don't get too hung up on the words, the actual words stretch and or compress. If your factor is greater than 1, the question will be phrased as stretch. If the question, or if your factor is less than 1 and positive, the wording will just say compress. So just vertical compression or stretch, you're multiplying your entire function by some constant. Horizontal compressions or stretches get a little tricky. These guys can get complicated, so be very careful here. Given a function f of x, we can horizontally stretch the graph by a factor of c by writing f of the quantity x divided by c, where c is greater than 1. So now we're not taking the variable x and multiplying it by c, we're multiplying it by 1 over c. So that's the thing you have to keep in mind when you're doing a horizontal compression or stretch of any form. You're taking the variable or the argument, you're multiplying it by 1 over whatever number you're given here, and you're taking that quantity, and that's replacing any x's that were in your given function, f of x. We can horizontally compress f of x by a factor of c by writing, again, f of x over c, where in this case c is between 0 and 1. So let's do some sample problems here with these horizontal and vertical compressions or stretches. So let's write the function obtained as a result of vertically stretching the absolute value of x by a factor of 8. Key words here, vertically stretch. We're taking the entire function, we're multiplying it by whatever our factor is. So the absolute value of x is going to turn into 8 times the absolute value of x. Pretty basic there. Next one, we're going to write the function obtained as a result of horizontally compressing x cubed by a factor of 2/5, and then shifting that down by 3 units. So we have a horizontal compression and then a vertical shift down. taking care of the horizontal compression first. Recall, if we are horizontally compressing by a factor of, in this case, 2/5, we are taking x over 2/5, and we're having that take the place of any x's within my given function. So where we have the x here, we're going to replace it with x over 2/5. That whole thing is being cubed, and x divided by 2/5 is the same thing as 5/2 times x. Just as a reminder, dividing by a fraction is the same thing as multiplying by the reciprocal. So there's our horizontal compression. Now we just need to take this thing and shift it down by 3. So I'm just going to subtract 3 from the end of this thing here, and we get 5/2 x, that thing cubed, minus 3. And a third sample here, write the function obtained as a result of horizontally stretching the cube root of x by a factor of 4, and then shifting it right by 1 unit. So horizontal stretch followed up with a horizontal shift. Horizontal stretch by a factor of 4, I'm going to take the x that's in there, I'm going to divide it by 4, and that's what's going inside of my cube root sign here. So the cube root of x after the horizontal stretch becomes the cube root of x over 4. Now shifting this thing right by 1, the variable here, the x here, this thing is going to be replaced by x minus 1. You take the x, you replace it with x minus the number of units you want to shift it right. So we have, in the end, the cube root of x minus 1 all divided by 4. The last type of transformation we can do with graphs is a reflection. We can reflect it over either the x-axis or the y-axis. If we want to reflect a function f of x over the y-axis, we just multiply the entire function by a -1, or just put a minus sign in front of the entire function. If we want to reflect it over the x-axis, we're going to multiply the variable x by -1, and we're going to replace minus x for any x's in the given function f. So in what order do we do these transformations if it's not specified? The general order is as such. First, you're going to take care of any reflections that have to be done. Then you're going to take care of stretches or compressions, vertical or horizontal. And then lastly, you're going to take care of those shifts, whether they be horizontal or vertical. So let's do a few more general ones here, just seeing how all these things can happen. So write the function obtained by reflecting x squared over the y-axis and then shifted left by 3. So reflecting over the y-axis, going back, we take the entire function and we multiply it by a -1. So the x squared is going to turn into the minus x squared. Now we're going to shift it left by 3. This is a horizontal shift. We take the variable x and we replace it with the quantity x plus 3. So we have minus the quantity x plus 3 squared. Write the function obtained by reflecting 1 over x over the x-axis and then vertically compressing it by a factor of 5/9. So first we are doing the reflection over the x-axis. When we reflect over the x-axis, we are replacing any x's with a minus x. So the 1 over x turns into 1 over minus x, and another way that we can write that is minus 1 over x. Either way, whichever form you left it in would not matter. you would be good. And then vertically compress it by a factor of 5/9. You're just taking this thing here that you had and you're multiplying it by 5/9. And that gives you minus 5 divided by 9x. So this concludes our video on transformations of graphs. You can take each of these basic functions that we talked about, the identity function, square function, cube function, all those things. You can plug them into your TI-83 or TI-84 graphing calculator. You can see how those things look, and then you can graph some of these transformations as well and see what these things look like. So this is how we determine the algebraic change or the change made to the function itself, just given a list of transformations that have to be made. If you have any questions or comments, please be sure to reach out to me, guys. Send me an email, give me a phone call, throw me a really good paper airplane, whatever you have to do. Otherwise, until the next video, take it easy.